Welcome again to Let's Talk Chemistry with Pastor Dan. We're looking at the combined gas law. Now we have these three gas laws we talked about: Boyle's law, Charles' law, Gay-Lussac's law. Remember, Boyle's law is constant temperature. Charles' law is constant pressure. Gay-Lussac's law is constant volume. Now, chemists are by and large a lazy bunch. We want to do the least amount of work possible. Since we have all three of these laws that are very similar, we can take them and put them all together into one specific gas law. Now that doesn't look too good there, so let's make it look better. There we go. That's the combined gas law. P1 V1 over T1 is P2 V2 over T2. Now, we could use that equation even if we're dealing just with Boyle's law or Charles' law or Gay-Lussac's law, because if it's constant temperature, we just take the temperature out here and you've got Boyle's law. If it's constant pressure, we take the pressure out, and we've got Charles' law. If it's constant volume, we take the volume out, and we've got Gay-Lussac's law. So let's take a look at some of these and see how they work. All right, so find the volume of gas at 35.9 degrees Celsius and 741.9 torr. If it's a volume of 254.9 milliliters, temperature is 25.9 degrees Celsius and 1.009 bars. Now remember that if prepositional phrase, when, as, for is a good divider, so we can keep that straight in our heads. So we start with our if, and that's our divider. So our volume, we don't know the volume before that, so volume 1 is unknown. Pressure before that is 741.9 torr, and temperature is 35.9 degrees Celsius. But remember, we don't like degrees Celsius because we don't like 0 in there, because divide by 0, undefined, we convert it to Kelvin. Do that by adding 273, and we get 308.9. Now, after the F, the volume is 254.9 milliliters, and the temperature is 25.9, which converts to 298.9 Kelvin. Now, you might notice my pressures here. They're not the same. So we got to convert. Let's convert this one from bars to torr just to make it similar. So put it over 1, and we do our equalities from the constants we know. That 760 torr is equal to 1.013 bars. Bars cross out. We're in torrs. So we get 757.0 torr. All right, so we use our combined gas law. We're solving for V1. So we write V1 down, write the other side down as is P2 V2 over T2 over here. Now P1 is in the numerator, so it's going to be in the denominator when we move it over. T1 is in the denominator. It's going to be in the numerator over here. Or the way to think about it, this was multiplied, so we're going to divide. This was divided, we're going to multiply. So we end up with V1 is P2 V2 T1 over T2 P1. Moving the values across as they work. Put our values in. We're going to get 757.0 torr times 254.9 milliliters times 308.9 Kelvin. Hit equal using your calculator. Divide by 298.9. Hit equal. Divide by 741.9. Hit equal. And then remember, check our units. Torrs cross out. Kelvins cross out with a milliliter. We have 4 sig figs, 4 sig figs, 4 sig figs, 4 sig figs, 4 sig figs. That one's easy. It's got to be 4 sig figs. So we get 268.8 milliliters. All right, let's do the next one. Determine the pressure in atmospheres. When the volume is 778.09 liters, the temperature is 9.22 degrees Celsius. If, there's my divider word again, if is my divider, at STP, the volume is 81.99 liters. All right. So if is my divider. So before the if, I don't have a pressure, but it says it has to be in atmospheres. So that's my question mark. 78.09 liters is the volume. Temperature is 9.22 degrees Celsius. Got to change it. Add 273. We get 282.22 Kelvin. All right, how about P2? Well, it says STP. Go back to that list we did when we talked about the gas laws, all the equalities. In atmospheres, that's 1. And then the temperature there is 81.99 degrees Celsius. What's standard temperature? 0 degrees Celsius. Again, we don't like 0, so it's got to be 273. All right, so we take our combined gas law, which is right there. And then we're going to solve for P. Now that means this time we'll write P1 down, P2, V2 over T2 down, and then V1 is in the numerator, so it's going to be in the denominator. We'll move the opposite side. T1 is in the denominator, numerator on the opposite side, or V1 is multiplied, so it's going to be divided, and T1 is divided, so it's going to be multiplied. So we end up with P2, V2, T1 all over T2, V1. All right, put our values in. 1 atmosphere times 81.99 liters times 282.22 Kelvin. Hit equal in the calculator. Divide by 273. Hit equal in the calculator. Divide by 78.09 liters. Hit equal in the calculators. Now let's check our sig figs. We've got 4 here. That's a constant, so it's infinite. We've got 5 here. Got 4 here. This is another constant, so it's significant. So 4, 5, and 4, least number is 4, so we'll have 4 sig figs in our answer. Get your calculator, multiply it through. Should get 1.085 atmospheres. All right, let's do the next one. Calculate the density of a gas at 109 kilopascals and 15.98 degrees Celsius if the density is at STP 2.009 grams per liter. Now, this one's different. It doesn't have volume and it has density. So how are we going to do that? Well, let's start with our values again. And then there's my if. So before that, we're going to have 100.9 kilopascals and 15.98 degrees Celsius. There's no volume there. No volume listed before, so leave it as a question mark right now. But how about afterwards? Well, density, remember we talked was grams per liter. That's what density is. Mass, so that means I have 2.009 grams per 1 liter. Now, do gas laws affect mass? No, mass is always the same. But does the volume change? Yes. So since the volume changed, that means the density will change in that division problem. So the only volume we have is right here, 1 liter. So therefore, I'm going to have 1 liter from my volume. My standard in kilopascals, going back to that list we had at the beginning of the problem set, 101.3 kilopascals, standard temperature 273. All right, combined gas, I forgot to convert 288.98 Kelvin at 273. All right, awesome. Combined gas law. We're solving for V1. Put the other side down, P2, V2 over T2. We're going to take P1, move it down, T1, move it up, bring them up, and then put our values. So we're going to get V1, P2, V2, T1 over T2, P1. Put our values in. 101.5 kilopascals, 1 liter, 288.98 Kelvin, equal on the calculator, divide by 273, equal on the calculator, divide by 100.9 kilopascals, hit equal, and we get 1.063 liters. Now, is that what I asked for? Did I ask for volume? No, I asked for density. Remember, I said that the mass doesn't change. So density is still 2.009 grams, but the volume now changed. So we put that new volume on the bottom. So taking your calculator, take 2.009 and divide it by 1.063, and you should get an answer of 1.890 grams per liter. All righty. Okay, so here's a problem set. I want you to pause and try that again. Try it on your own. Here's the if as a divider. See what we come up with. Pause it. All right, here we go. So this is our answer. Our P1 is 760, volume is unknown. T1 is 273 because those are standards. 727.9 torr is afterwards. Temperature is 48.2, volume is 48.277 liters. The temperature is 29.05 plus 273 is 302.05. V1 is P2, V2, T1, crossing the values up as we go. Put our values in. Answer is 41.75 liters. All right, awesome. Hopefully that wasn't too bad. Take care. God bless. Bye.